Hey everybody, this is Larry. This is me doing the weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Apparently this is a medium one, 291 word pattern 2. And apparently I've solved this before. A medium. Given a pattern and string S, return true if S matches the pattern. What does the match mean? Oh, I see. This is the thing where a character matches some word. The key thing to know, I mean, you can think about some clever stuff, but the first thing that you should do is hit the like button, hit the subscribe button, and join me on Discord. But also, it's really hot in here. I just came from the outside, so maybe that's the case. It is 80 degrees outside, which is, what is that in Celsius? 26 degrees Celsius today. So it's a little bit hot, and I just came back from running for 8 miles. Yeah, okay, so the idea is just brute force, right? There's 20 things. It's good enough to brute force. We don't have to really think about it that much more. Not to say that this makes it easy, but you know, it is just doable. So we'll see. And even with brute force, you have to be a little bit smarter, but that's okay. We just have to return true force. So okay, so then now we can maybe just do like can match, and technically, look at it this way. You have index, maybe p index and s index. Yeah, and then like a lookup thing that we have to keep track of. Right? And that's basically really all. I mean, this is a brute force thing, right? So that's basically all you have to do. I think it is very easy to make a mistake on the complexity, but the idea here, and you have a P and an S or N or whatever that I did. But the idea here is that you really just have to brute force on s.length, right? So if you're really naive about it, or like if you're naive, if you want your algorithm to be as naive as possible, you can actually just partition s sub length 2 to the 20 or 2 to the 19, because in 20 characters it's going to be 19 partitions, right? And that's going to be like 500,000 times 20. It's not great, but good enough, right? Maybe. But ideally, you do it that way, and then you do a check, and it's fine. But the reason why we want to do it recursively is that it allows us to do some inherent pruning, right? Meaning that we cut off some branches, save some time, make it slightly faster on the average case, if not the worst case, because the worst case is just going to be the worst case, right? I mean, the worst case is the case where it's forced, I suppose. So, yeah. Okay, so let's see, right? So then now we go, okay. So then now we want to check if s index is equal to n, then we're done anyway, right? Well, kind of. We have to check that if p index is not equal to n, then we return false, because that means that we still have p patterns to match, right? Otherwise, then maybe I could write this in, I don't know. Maybe this is a little bit more clear. And this is wrong anyway. This is p, not n. But okay. And then now, if s index is equal to n and p index is not equal to p, then we return false, right? And then same thing, right? If p index is not equal to p and s index is not equal to n, then we have some stuff that is not matched. So then we return false. Otherwise, then we can just continue on the brute force. And on the brute force, what are we doing, right? There are a couple of ways you can do it, but first we'll look at the pruning, which is if lookup of pattern of p index. Well, maybe I wrote this in a weird way. If this is in there, what does that mean? That means that we have to let me add a comment. That means that we've already assigned something to pattern p index. Let's see if we can reuse it, right? A byte. Oh, okay. Yeah, you have to check that character maps to two different strings. That's easy. No two character. We have to check the other thing too. The two character has to be. So now we have to do two lookups, right? Maybe a lookup and an or lookup. And basically looks up pattern to S, and then or lookup is for S to pattern. Right? Okay, so let's say this is the case. Then what do we do? Then now lookup of pattern of P index is going to be the current match string. So maybe I'll just call it M for match. And then we just check whether, if S of S index and then S index plus length of M is equal to M, then we're good. So that means that we can keep matching. So we can return, and we have to, right? Because we assume that this pattern, we have to reuse it. There's no choice, meaning we cannot skip it. So we'll return can match P index plus 1, S index plus length of M, and we don't change our lookup or lookup, and we don't change any of the state, in fact, because, well, why would we need to? Because this is already done. Otherwise, then now we brute force mapping what's it called? Patterns of P index, right? So then now we go for N, I don't know why, but for index N, right? So then now we can construct a current string. So let's just say, and I don't know, but it's fine. S of S index and N, right? N plus 1, I think. Yeah. Easy to make mistake. I make mistakes like this all the time. But yeah, and then now we have to look up if. So then now we want to check up that if current is in or lookup, then that means, what does that mean? That means that this already has a lookup, but it does not match this thing, because otherwise this would already be in it, right? So that means that we skip, because this is not a valid setup, right? Because if this is in reverse lookup, that means that because you have to have two, it matches in both directions, that means that lookup of the current pattern is going to be in current. Otherwise, we know that pattern P index is not in lookup, so we set this to current, and we also set reverse lookup of current to pattern of P index. And then now we can, if can match, well, let's just say good is equal to can match of P index plus 1, we just go to the next index, S index plus length of current, because that's how many characters we consume. I guess that's actually N plus 1, so we don't even need to do the math quite like this. Yeah. And then lookup, and of course afterwards we want to reset this, right? So we want to delete our lookup of current, and I think we should be able to look up a pattern of P index, because this assumes that we haven't used this. I think that should be good. Maybe I'm missing a case. I feel like I'm missing some stuff, to be honest. But yeah. But the reason why I want to do this is and set this is that because then now we can do if good, we return true. So we could terminate early, but we want to reset the states before we return, which is why there's this thing here. Anyway, okay. So then now if we tried all the things and it's still no good, then we return false. And then now we can return can match 0 0 just an array and not an array, a hash lookup, and that's it. Let's give a spin. Key error B. Why is that? Oh, I see. How do I want to clean this up? So the reason why this is given an issue is because of this part, right? meaning that if the same thing can pop twice from here, but we would delete it before we need it. So how do I do this? I mean, I guess if you think about it, things in terms of pure, that's weird though. No, that doesn't make sense, does it? To be honest, I'm a little, like I could see why, but I'm not quite understanding why. Because this only happens within the same context. Like I see that maybe we make multiple calls to it, but oh, I see. We have to return false here is why. Because I was like, this looks really awkward. But because, if this is not true, then we just return false because pattern is already in it and we're not matched, right? Okay. I was like, something felt a little bit weird. But yeah, okay. Okay. I mean, this looks good. We'll give it a submit to see if it's actually good. Oh, nice. Consistency is key. Last time apparently I got 3 wrong answers, and that wasn't that long ago. Huh. I guess I did this as a random problem, maybe, because that was only I honestly do not remember this problem. What did I get wrong on? I mean, I did basically the same thing. And I even did this correct. What is this? Huh. Oh, because I don't. Well, I mean, I did this right. I don't know. I mean, I don't want to debug a month ago. I guess I don't know. I don't remember this at all. Even though I got 3 wrong answers, I do not remember this at all. And I think I wrote it cleaner this time. Maybe. I just forgot the return false case. I don't know. But yeah, this is going to be, because the number of ways you can partition S is going to be, n times. So it's going to be 2 to the n. Each. And I want to say that is probably p times 2 to the n, because there's like this if statement here that we check every time. And there's a lot of stuff. I don't know the complexity. It is exponential. I don't know why it's run so fast actually, but I guess the inputs are not super tight. And apparently I only did it like a month ago. I actually do not. I mean, it's probably one of those random problems that I solve, but I do not remember this at all, to be honest. But But that also goes to say, if you get to a level where, these problems, they all kind of look the same. Like, I'm not surprised I've done it before, but I also don't remember. Or like, I wasn't surprised I'd done it before. I just am surprised I did it a month ago because I don't remember it. Usually I don't remember it because it was much longer, but older. But anyway, that's all I have for this one. I'm going to show you the top again because it's slightly longer than, if I can just do it this way. And I don't even do this. Well, I guess I do use length of M. But yeah, that's pretty much it, really. I'll make it slightly smaller so you can see in one page. And that's all I have. Thanks for watching. I'm going to do an extra problem today just for fun. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.